Okay, so in the last video, we established a pretty profound thing in arithmetic. And this was algebraic relationships and the fact that having common products, so say, let's go 3x plus 4x, having some common thing multiplying by both of these two numbers allows us to establish a relationship between these. And this is the fact that once we have this, we can just add the coefficients there. I took a really deep dive into this in the previous video, so feel free to watch that one if you want to get a little bit more context. But this video is assuming you've watched the last one. But this thing we can write as 7x. Now, we looked at the addition case before. So we're going to take a quick look in this video at the case of when we subtract this. And as I talked about in the previous video, what's great about algebra is this applies these rules to a greater scale. We looked at one particular example in the previous video, but this extends it to any number, to these x's and y's or any letter, any pronumeral, to represent any number, and it works for any number. Now, let's look at another case. Now, let's say I had 5x, and from that I subtracted 3x. So from the same idea from the last video, we can simply subtract the coefficients. So subtracting 3 from 5, we get 2x. Now let's actually just test this, because let's just not take my word for it. Let's actually test this with a few values. Now, I'm actually going to write this one more time. So 5x minus 2x equals 3x. Now, we can show, well, this relationship will hold for any value of x. Now, feel free to try as many as you'd like at home, but I'm just going to quickly do one example. And I'm going to pick a really large 4-digit number, right? So I'm going to say, I'm going to let x equal to, let's go 9,647. So I'm willing to say that if I were to multiply, and it's important to note that x shows up in each of these terms. If I take 5 lots of x, and from that I subtract 2 lots of x, I will be left with 3 lots of x. Now, this makes sense when algebra is taught initially, because we say, all right, well, we have like terms, so just subtract or add the coefficients. But in the previous video, I looked at kind of why this works. But let's actually look at what happens when we actually sub in this value into our x. So 5 lots of 9,647 and subtracting from that 2 lots of 9,647. First of all, let's just see what this gives us. On the left-hand side. So 5 lots of 9,647 gives us 48,235. I purposely used a big number just to demonstrate this. And 2 lots of this number, I get 19,294. And let's perform this subtraction on the left-hand side. I will get 28,941. And if everything I've told you about algebra is correct, then this should be equal on both sides. So my number here, whatever I get when I multiply 3 by 9,647, that should be the exact same thing as this. Now let's check it out. And lo and behold, when I put that into my calculator, I get the exact same thing. Feel free to check this out at home if you don't believe me. But it's kind of like magic because I can pick any number because our rules of algebra apply to general patterns in arithmetic that we notice. This statement up here will be true for all x. Throw anything into this x, any sort of whole number integer into here. It'll even work with fractions. And see at home, see for yourself if you get this relationship. And this, we will always get this equivalence because the algebra works. And the algebra works because our arithmetic works. So algebra just takes arithmetic and what we know about that and applies it to an even bigger scale. And using this, now this leads us to understanding how to solve equations and why this stuff works when we have algebraic unknown pronumeral terms. But that is a bit of a deep dive into adding and subtracting like terms in algebra. And we will continue with this in future videos. I'll see you there.